Hello everyone and welcome back to Fusion 360 Live. I'm your host Jason Lichtman, Technical Specialist here at Autodesk, and I'm going to walk you through an easy and practical project. This is going to be very beginner friendly, and I'm going to teach you some of the guiding principles to design even much more complicated projects than the one we're going to start off with. But this should get your feet wet in something that's useful and easy. Today, we're going to be talking about a light switch guard. And let me show you what we're talking about here. Here you could see a light switch guard on my Fusion 360 screen. And what this is going to do is it's going to prevent toddlers or anyone else, even yourself, from turning on a switch that you shouldn't turn on or turning off a switch you shouldn't turn off. The first question you're probably asking is, why would you ever want something like this? Well, let me tell you. First thing you should know about me is that I have a little person in my life named Hayden. He's 2.5 years old at this point, but when he was a little bit younger, he loved turning switches on and off to see what happens. And I didn't mind it too much until he started turning on and off things like a gas fireplace. Or maybe when he got into the kitchen, I was a little bit concerned that maybe he'd try to turn on something like a garbage disposal. And so with something like this guard, it means that he can't turn on the switch he shouldn't turn on. He also can't turn off a switch that I don't want him to turn off, but I still can. So think of this as like a child-resistant light switch. And I think that this is a great project for Fusion 360 because it's really simple. We're going to be able to design this in a single sketch, a single extrude, and a couple of fillets. Oh, and by the way, I'd want to show you this in action. So this is a quick little video of the very first light switch guard that I put in my home. And you could see my son trying to turn that light switch on, and he can't do it. I don't have it in the video, but in my case, if I wanted to turn on that same light switch, all I do is bend the little arm out of the way, in this case to the right, and I'd be able to turn that light switch on without any problem. So let's get into the good stuff, and we'll start here in Fusion. We're going to start with a new file. We're going to go in this file right here. And in this particular case, I already modeled up the light switch cover or the light switch plate. But even if I didn't, I can start from scratch as well. It's really your choice. So we're going to go and turn off this particular body. I'm going to go and turn on the little light bulb next to origin, and that allows me to see where I am in 3D space. If you're first starting out in Fusion 360, I highly recommend you turn on the little light bulb next to origin. You can see that this white dot here, that's the origin, that's the center of my 3D world. The red line here, that's the x-axis, the blue is the z, and the y is the green. And if you ever can't remember which one is which, I want you to think back about those red, green, blue projectors you might have seen in people's houses or at movie theaters. Well, RGB, X, Y, Z. It's that simple. We also here have planes. This one is the XY plane or the front plane. This one here is the YZ plane or the right plane. And this one here is the XZ or the top plane. We're going to go and pick one. In this case, I'm going to choose the front plane or that XY plane. I left click to select it and right click to create a new sketch. Now that I'm in the sketch, I could see the sketch palette on the right-hand side, and I could see that I'm in the sketch tab up top. By the way, if you don't see this set of tabs like I see, keep in mind that you're probably not using the new user interface. To turn on the new user interface, go to your preferences, under your name, Preferences, and the very bottom tab is going to say Preview, and turn on the UI Preview. After you restart Fusion 360, you should see what I see. I'm going to go and grab some different geometry to start with. Under Create, you could see that I could draw lines and rectangles and circles and arcs and a whole bunch of different shapes. In this case, we're going to start with a rectangle. I'm going to choose a 2-point rectangle. And if you're not familiar, the difference between the different rectangles are simply how you draw them. They're all just rectangles. I'm going to go and choose a 2-point rectangle and draw a quick rectangle. I like to add center lines so I can make sure that everything is symmetric. So I'm going to go to Create, Line, and I'm going to draw a line from the origin up to the very center of the horizontal top line. And you'll notice that when I put my mouse near the very center, a blue triangle shows up. And that blue triangle is showing me that if I click here, it's going to add a constraint. And that constraint is going to be the same constraint I see up here called midpoint. It's going to lock into the center of that line. Let's go and do that again. I'm going to click the origin, and this time the very center of the right vertical line. And now we're going to go and add some more constraints to be able to make sure that everything is lined up correctly. I'm going to add a horizontal or vertical constraint to this line to make it vertical, and this one to make it horizontal. And now everything snaps and is centered. In fact, if I go and I grab my square, you'll see here that everything I do at this point is going to be symmetrical. Now, if I hover my mouse over that square, you'll see that it breaks it up into two sections, the upper right quadrant and then the rest. And the reason is because this vertical line here and this horizontal line are breaking up my section. And in this case, I don't want it to do that. And for that, all I have to do is convert these lines into something called construction. And you'll see that right here in the sketch palette on the right-hand side under construction. So if I select that option and choose these different lines, we'll go and turn them into dotted lines that represent construction. And now when I move my mouse over this square, it's going to highlight the entire square and not separate it into two different sections. This is exactly what I wanted. Let's go and do this one more time. We're going to create one more rectangle. This time I'm going to use a shortcut. The default shortcut for a rectangle is a letter R for rectangle. Very intuitive. We're going to click R for rectangle and draw another rectangle here. And this time, it actually made it into construction geometry automatically. I can actually double click on this rectangle, hit construction, and put it back into regular geometry. That's what I wanted. Let's go and put some dimensions on this so far. We're going to go with a horizontal dimension of 79.75. And that's what I measured my actual light switch cover to be. We're going to also add a vertical dimension, and this one's going to be 116.75. Perfect. And you'll notice that my rectangle went from blue colored to black, and the reason is because at this point I added enough dimensions and enough constraints to fully define the rectangle. The software doesn't have to think about, did I want this or did I want that? It knows exactly what I wanted because I fully defined it. That's the fancy word we use for it. I'm going to do the same thing for the smaller rectangle. We'll go and add a dimension. Maybe we'll start with a vertical. This is going to be 24.75. And we'll also add a horizontal. This one is going to be 11 millimeters. And you'll notice that the rectangle, even though I put the dimensions on, is still blue. And it's because I didn't yet define everything about it. In this case, I didn't define the position. So I can go and move this rectangle wherever I'd like, including approximately in the middle here. And then we'll go and add another constraint to fully define it. And this one we're going to use is called symmetry or symmetric. Under constraints, I can choose symmetry. And in this case, the order that you click very much matters. So let's go and make sure we get it in the right order. We're going to go and select any of the lines that I want to make symmetric, then the second one, and lastly, the line that's going to be in the center. So let's go and choose the left vertical, the right vertical, and then the center line. And off it went, and it not only snapped into place, but it also turned it black for fully defined. Let's go do this again for the horizontal, and now that's snapped as well. There's only one more thing that I need here, and that's going to be the location of the screw holes, because I'm going to want my 3D printed part to fit with those same screws. So let's go and put those. For circles, we can use a shortcut C for circle, very intuitive, just like before. And I can go and draw a circle here, and we'll make that not construction. And then I'll go and add one more circle down below. And actually, another thing I could do that'll make my life easier, let's go and delete this bottom circle, is I could actually go in and say create mirror, and I could choose an object that I want to mirror, and it'll automatically draw it and apply a symmetry constraint. So that's a little bit of a shortcut for any of you beginners out there. We're going to choose the object is going to be the circle, and then the mirror line is going to be this horizontal line, and we're going to say OK. And as a result of applying that mirror command, now if I move the topmost circle, it'll move the bottom. And also if I change the size, it'll also change the bottom. So that's perfect. We're going to do that one more time. I'm going to draw another circle up top. We'll go and add my symmetry and mirror that as well. And now we're looking really good. Let's go and put some dimensions. We're going to make one of these, the bigger one, 6.85 millimeters, again from measuring my actual faceplate. And then the smaller is going to be a hole that's 4.25 millimeters. The only thing left to fully define this sketch and be able to move on to the next part of our design process is to make sure that I get the dimension between the holes correct. In this case, it's really simple. It's only 60 millimeters. So go and add that, type in 60, and now I'm good to go. If I move my dimensions out of the way or even hide the dimensions, now you can see exactly what I'd expect. And by the way, you can hide your dimensions and you can also hide your constraints. Both of the showing and hiding dimensions is actually new as of our update about a month ago, maybe 6 weeks ago, and the show constraints has been around for a little while, but now I'm seeing everything and it's looking really, really good. So let's move on to the next part where we design the actual guard. So we're going to go and finish this sketch, and we're going to go and create a new sketch on the same front plane, create a new sketch, and now we'll go and design the really fun stuff. To start off, we're going to want to go and project some geometry from the original sketch. And if you're not familiar with that term, let me just define it for you. The sketch that we created was sketch number 1. We're creating now sketch number 2. And although I can see sketch number 1 in the background, if I want to use geometry from that sketch, I do need to project it so that sketch number 2 looks at sketch number 1 for that particular geometry. And if I ever change sketch number 1, the geometry shown as projected in the second sketch will also update. For that, I can go to Create, Project, and then choose the Project feature, or I could just hit P for Project. I'm going to go and choose the larger of the two holes, the two circles, and say OK, and now we're good to go. In fact, if I go and I hide that original sketch, you'll see at this point all I see are the two circles, the two projected circles, and they're magenta because they're projected. That makes it a little easier for me to see that they're projected. And so at this point, if I want to use the other sketch to keep it in the background, I can, but I don't need to. It's really my choice. Also, what I could do to help me out is I could bring in an image, and we call those attached canvases. So let's go and bring in an attached canvas, and then we'll use that to trace our design to make it a little bit easier for us. So I'm going to go under Insert, an attached canvas. I'm going to choose the plane that I want to bring it in at, and I'm going to go and select the image itself for my computer. We're going to go to the folder that I have ready to go, choose the screenshot, and as you can see, the image is not exactly the correct size. But we can fix that very easily here in Fusion. We're going to go and choose this screenshot under the left-hand side, under Canvases, and we can right-click and we could say, let's calibrate this image. And if you're not familiar with calibration, what we're going to do here is we could pick any 2 points on this image, and it'll allow us to override the dimension to whatever we want. So if we know already that the center of this screw hole to the center of this one is 60 millimeters, all I have to do is type in 60, and it'll automatically scale the image to the right size. And that's perfect. That's really helpful. Now I can go and reposition this if I need to, but it already happens to be centered, so my life is a little bit easier. But if I did want to go and recenter it, I would right-click on the image, Edit Canvas, and then using these manipulators, manipulators is what I meant. Got to make sure to put the right emphasis on the right syllable. But if I go and I orient this the way I want, then I'm set up and ready to go. So here I am. It's all set up. Let's go and draw. Now, we're going to go and reorder things just a little bit. I'm going to reorder my canvas slightly. And now when I go and I draw my sketch, I can actually see the canvas in the background. That'll make things easier for me. Let's go and add some circles, because if I zoom in here, you could see that the majority of this design is actually circular. So I'm going to hit C for circle, click on the very center of the projected geometry, and I'm going to draw a circle approximately here. The exact dimension doesn't matter for now. We're going to go and do that again, and we're going to go and do that again. Now I can go and put dimensions on this to be exactly what I want. So for example, if I want the thickness of this region from here to here to be, let's say 3 millimeters, we'll go and override that number, and it's looking good. Maybe I also want to define the thickness of the actual arm that's going to be bending. And keep in mind that this number is actually very important. This is going to define the flexibility of your part. This is actually one of about 5 different things that'll all define the flexibility. And I will make sure at the end of this particular webinar, I'll cover what all 5 of those different variables are and how you could change them to suit your particular needs. But for now, this is one of them, and we're going to go in dimension between them, and I'm going to set this to be 5 millimeters. Now at this point, my circles are still blue, they're not fully defined, and I can go and stretch this wherever I want, and as I do that, it's going to maintain 5 millimeters from this circle to this one, and maintain 3 from this to this one. In fact though, this one, the smaller, is fully black because it's fully defined, because we know where the screw hole is, we know what the offset is, it knows everything that it needs. But this outer one hasn't been defined yet, so we're going to go and drag this in to get this to be where we want, or we can go and put a dimension on it. And there are a variety of different ways I could put the dimension on, and one of those ways is I could define the outer size, and I could set that to, let's say, 27.5, and that'll match up how I want it. Or if I want, let's go and undo that. I'll go and delete this dimension. I could also set the dimension between this, like what's this gap over here, and I can make that gap as big or as small as I want and get the same result. Once a sketch is fully defined, like you see here in these circles, if you add another dimension, like the outside, once I already defined it via the inside, you're going to get a warning like you see on the screen right now. And that warning is telling you that adding the dimension will over-constrain the sketch. And if you choose OK, it's going to create a driven dimension. And so what I want you to think about in this case is a driver and a passenger in a car. You can only have one person driving the car. Backseat drivers not allowed in my household. So in this case, you have the driver being the dimensions we've already defined, and we're going to allow this dimension to be a passenger. And we denote that with parentheses around the number. And if I want, I can actually change which of these dimensions is the driver and which one is the passenger. To do that, you need to take the driver and demote the driver to be a passenger. Let's go and do that. I'm going to take this 2.25, right-click on it, and toggle it to driven, which is now making it a passenger. The sketch turns blue again because now I can actually drag my sketch and change the size if I want, and it will update both of these driven dimensions because both of them are the passenger. But I can also promote one of the driven dimensions, whichever one I want, to now become the driver by toggling it to driving. And now the parentheses go away and I could change the value to whatever I'd like, including, let's say, 27.5. That's looking pretty good. We'll go and look at that a little bit more in just a moment. Let's go and start to define what it's going to look like connecting the top area to the bottom. For that, we're going to go and draw a line, and I'm going to use the shortcut L for line, and I'm going to go and draw a line starting on this outer circle, and you'll notice here that if I select right now, it's going to add, there's a blue icon just at the start of this line that'll automatically make this line tangent to the circle. If I move this away, it's not going to do that. I could choose to do it later if I'd like. So depending on where you drag the line, it's going to add constraints. If I add it where I have it right now, it's going to add a vertical constraint. And if I add it around here, it'll add a tangent constraint. There is no right and there is no wrong. Both are right. You can choose whichever one you want. There is no problem either way. So let's go and use maybe a vertical. And then you'll see that this line is still blue because I can still drag this and move this over. But we can go and add more constraints. And so under constraint, you'll see one that we haven't used yet called tangent. You'll see that right here. I could choose this line and this arc, and it'll snap it to the closest available tangent location. That's off on the left. And now you could see that this line turned black because it's fully defined, except the endpoint, because I could still drag this and make this longer. It's looking pretty good so far. Let's go and draw another circle down here at the bottom. We'll use the very center of our screw, and drag this out. And I could set the dimension to this circle and make it match 27.5. But I run the risk, of course, if I change the dimension up top from 27.5 to, let's say, 30, the bottom one doesn't adjust. So there are a couple of ways I can go about fixing that. Let's go and undo that, and we'll undo our dimension down below. Here, what I could do is I could double click the dimension, and instead of typing in a value, I could actually click on the dimension up top, the diameter of that circle. And now this dimension is going to look at D126, which happens to be this dimension. And so if I change the top value from 27.5 to, let's say, 30, the bottom one is going to adjust automatically. So that's one really convenient way to make the match. But one of the cool things I think about sketching is that it brings me way back. And it brings me way back to the days that I was in geometry class. And the reason is because all of 2D sketching is a collection of geometric shapes, and how they interact with each other, those constraints, are based on geometric rules. And so if you're good at it, or practice to become good at it, you'll start to see patterns and different ways that you can constrain things to get the results that you want. And at the end of the day, there are multiple ways you can get to that end result. It's your choice on how you want to get there. So if you want to make the bottom circle match the top circle by having the dimensions match, perfectly fine. If you would like to make them match in another way, then that's also perfectly fine. Let's go and take a look at this together. And here, one moment, there we are. Here you can see I'm going to go and delete this dimension entirely. This blue circle is free to move, but I can also go and add that tangent constraint that we talked about. And now it's automatically going to match that circle. So just like before, if I change this value from 30 to maybe 35, the bottom circle is going to adjust automatically. So there are multiple ways you can make this set of geometry match each other. Let's go and set this back to the correct number. That was 27.5, and we're good to go. Now if I zoom in here, you'll see that I have a little bit of an extra piece of my line. The line's a little bit too long. Well, instead of using a constraint, although I could use the coincident constraint and select the point, the end point rather, of this line and this circle, and it will automatically constrain it to match. The other thing I could do, if I go and I undo that for a moment here, is I can go under Modify, Trim, and trim is really neat because it'll do exactly what you'd think. It's going to trim my geometry. I can select, just by clicking with a left mouse click on this geometry, to automatically trim it to the next available intersection between the different geometries. Or if I want, and I would like to do this a little faster, I could also drag my mouse. I'm clicking with my left mouse and I'm dragging it, and anything that I select over will automatically trim as well. So keep that in mind. There are two ways to trim. Let's continue. So this was supposed to be 27.5. It looks like I undid just a little bit too much earlier. And let's go and add some more geometry. I'm going to hit L for line, and I'm going to draw a horizontal line. I'm going to go and put this approximately here. And then I'm also going to go and draw another line. This one's going to be vertical. And one thing to note that Fusion does that I love Fusion, but not every single thing that it does is something that I'm going to fall in love with. If I try to draw this line vertical right now, it's adding a constraint that is the perpendicular constraint. And that's not always what I want. So what I often do is I can avoid constraints from being added while I'm drawing my sketch by holding the Control key on my keyboard. And now I could draw this line wherever I'd like, even almost vertical, and then go ahead and add the constraint that I want, like this horizontal constraint. So that's a way that you can avoid constraints if you don't want it. Just to repeat, it's holding Control while you're going and adding your geometry. Now I can see here, if I zoom in, I have some extra part of my circle that I don't want. So let's go back to our trim command. That was T for trim is the keyboard shortcut by default. And we're going to take advantage of the method where I click and drag. So I'm going to click with my mouse, and anything that I hover over is automatically going to trim, just like that. And I'm also going to take advantage of clicking once to trim what I want, and we'll go and click right here, and the red preview is showing you what to expect when you click. So there we go. So we're pretty trimmed out right there. Let's go and add a dimension, And I want that dimension to be from this circle here to this line. And I'm going to show you what happens if you go to dimension this the way that you'd expect. You might not get exactly the results you want. So I'm going to hit D for dimension. I'm going to click on the circle and this line. And what I get here is a dimension between the center of the circle and the line. But that's not exactly what I wanted. What I want is a dimension between the top of the circle and the line. And for that, I'm going to go and hit D for dimension. But this time, before I click on any of the geometry, I'm going to right-click, and I have an option here. The default is to pick the circle or arc center, but I can override that and pick the circle or arc tangent. So in this case, when I pick this circle, and then I click on this line, it's going to give me the dimension between the top of the circle and that line, and I'll go and override that to 5 millimeters. I can also go and take this blue line. You'll see that this one is free to move as well. It's not constrained yet. We'll go and add a dimension between this line and this one, and we'll make that about 7 millimeters. Perfect. And I'm noticing that I have some sharp edges down here below, so let's go and add a fillet. Under Modify, I can find the Fillet command. I can choose this corner by choosing the actual corner, or I could choose 2 lines and it'll automatically fillet it. And then I can drag the blue manipulator wherever I think is going to be ideal, including maybe also choosing to override the number, and I could make that 5 millimeters. Quick and easy. I'm also going to do a fillet right here in this corner. And I'm going to go and drag that down. And this one is going to be about 7.5. And that's looking good and also fully constrained. Let's go over here and start to define some of the more specific details. But overall, this is looking really good so far. So let's continue. We're going to go and take this line and I'm going to drag this up quite a bit. And then we're going to want to connect this line to this circle right here. And we're going to want to do that with a horizontal line in this case. So I hit L for line. I'm going to click near the bottom of this particular circle, and it's going to allow me to draw a horizontal line. Excuse me a moment. You'll see here that it's automatically adding the constraint that I don't want. So I'm going to hold Control and then select, and then we'll go and add the constraint that I do want, which is the horizontal constraint. Now, I could use trim to trim out these lines and make them match, but this is a great example of where I think constraints are actually quicker and easier than the trim tool. So I'm going to go and select this endpoint. I'm going to hold Control and hit this endpoint, and then now I'm going to hit coincident, and they'll automatically coincide with each other. But I see that this blue line is still blue, and I expected it to be black. Let's go see why it isn't. I can select this line and drag it, and start to see that I don't have tangency between this circle and this line, but I can fix that again by selecting both, holding Control in the middle, and then clicking tangent to apply that constraint. So nice and easy. Let's go and add a fillet here as well. Choose the corner. Oh, and by the way, we do have a trick that we're going to show you in just a few moments with fillet that I think you're going to like. I learned it from Brad Tallis just 2 weeks ago, and you'll see that in just a second. So here I have my fillet, and everything is looking good. We're only missing 2 things, and we'll go and turn this into 3D. The 2 things we're missing are the arm itself and how that comes down, and then of course how this piece right over here connects. And let's go and maybe do this piece where it connects first. I'm going to go and create an arc in this case. We're going to go and choose an arc, maybe a 3-point arc. I get to pick this particular circle here, another on this circle, and then depending on how I drag this particular arc, you'll be able to see tangency start to show up. And in this case, I'm not seeing any constraints showing up automatically, so we'll go and just add that ourselves. I choose tangent between this arc and this one, between this one and this one, and now everything in terms of the size is set up, but the position is now fair game. And I can go and put this into place and put a dimension, but the way that I would like to define this in this case is we're going to go and put an angle. So I'm going to go and draw a vertical line straight up, make that construction. I did it by choosing the letter X on my keyboard. That was my shortcut to turn it into construction. I'm going to draw another line across over in this direction, make that construction as well. We'll go and use that fancy trim tool where we can drag right through and trim our lines. And then I'm going to go and add tangency between this arc and this line. Now, all I have to do is drag the line and it automatically drags the arc. That's, as I was talking about earlier, about being able to use geometry for your benefit. That's all I was doing there. Nothing fancy. Now we'll go and add a dimension between this line and this one, and we'll set it to exactly 60 degrees. And of course, that arc now is black. It's fully defined and good to go. Let's go and add some geometry for the arm, and then we should be able to extrude this. I'm going to draw a line from about here to this particular circle. We'll go and draw one from about here to this particular circle, and we're going to go and add some more of our constraints. We're going to go and use the famous tangent constraint we're using a lot today. We'll make a tangent between this blue line here and this circle, the same between these two. And then lastly, at this point now, you could see that I could move these independently of one another, and I actually want them to be parallel. So let's go and add another constraint. We'll go and choose the parallel constraint between this blue line and this one. Now when I go and I drag this, they're going to move together. That's perfect. And I could try to put a dimension here between those two lines, but I actually don't have to, because this dimension, the 5 millimeters over there, is automatically going to drive the dimension between these two. And if you need proof of that, let's go and add a dimension. And I told you earlier that if you try to add too many dimensions, we're going to give you a warning that we're going to make that dimension a driven dimension or a passenger dimension, and you'll see that warning right here when I select. Adding this dimension will over-constrain the sketch. It's already fully defined. Choose OK to create a driven dimension, and here you see that it matches the 5 millimeters over there. In fact, I'll just prove it to you once more. If I change this from 5 to, let's say, 6, this one here is also going to change. Make it back. Perfect. So I have my shape here. The angle is not set at this point. I do want to focus on the end a little bit first, and then we'll focus on the angle. For the end, I'm going to do an arc, or create an arc, just like I did over in this region. We're going to go and create an arc from this endpoint to this one, and we're going to go and add tangency. It automatically actually added tangency between this arc and this line. You could see that constraint right there. And I could also add it to the other side. Perfect. So now the actual size of the arc is defined, and all I have to do is to decide where I'm going to put this. And this is something you're going to have to do a little bit of trial and error on. In terms of the left to right, that should be pretty obvious. I want it centered. But in terms of up or down, that's going to be where your trial and error is going to lie. So let's put this in about the right spot. It's going to be somewhere up top over here, and I want it to be centered. So I'm going to say, let's go and use a vertical constraint, which doesn't just have to apply to lines. It can also apply to circles relative to each other, arcs relative to each other, squares, whatever it is you'd like. So I'm going to go and choose the center of this particular arc, and then also the origin. And now it's going to fully constrain it, not fully, mostly constrain it, so that I can move this particular thing up or down, but left to right is not possible anymore because it's automatically centered. This is going to make my life easier. What I could do at this point is I could add one more dimension. I can go and choose D for dimension, but instead of choosing the origin to the center of the arc, instead we're going to go and right click again and choose to pick the circle or arc tangent. I pick the arc, I pick the origin, and it's going to put the distance between them. And I could set this to whatever value I'd like, whether it's 1 or 2 or 5, whatever it happens to be. And by the way, you're going to find here that you can't exactly put in a negative value. And so if I decide after the fact that I actually want this to be down a little bit further past the center, what I can do, a little trick for all of you out there, is I can right click on this dimension, make it a driven or a passenger dimension. It makes my entities blue, which means that I can drag them around at this point. I can now drag this dimension down wherever I want it. And you can see that this dimension is now showing 0.454 millimeters in this direction. So instead of showing you a negative, it just shows you the magnitude of the dimension in whichever direction you go. So if this case, it'll be positive going down, and if I drag this up, it'll still be positive, but it'll be going up. So if I drag this down, I could then go and take my dimension, right-click, choose to make it driving. Now my sketches all turn black as I expected, but I could change this value to whatever I want, and now it's going to be the value below the center line, whatever that value happens to be for you. Excellent. Another quick tip is you cannot make the value 0. So you could make it a very, very small number, like 0.00001, but you cannot make it 0. So just keep that in mind. So interesting enough, if I look at this whole sketch, as messy as it might look, let's go and hide the dimensions and hide the constraints for a moment. As messy as this might look, this is actually good enough for me to turn into our 3D geometry. I don't actually have to clean this up. And to illustrate that, let's go and choose under solid. Let's go and extrude this. And what you're going to find is that all of the different geometries that I added to my sketch are all going to show up as individual profiles. I can pick this region, I can pick this region, and I can pick each of these individually. And what it would be up to at this point is for me to select what is important for my design. So in this case, I would choose these regions right here, and it would actually extrude exactly what I expected. Let's go and show you that a little bit more firsthand. This is exactly what I expected. I mean, I extruded this too thick, of course, but this is what I would expect. And if you want, you can clean it up, and that would make your life easier. After all, when you go to extrude this, you do have to pick each of the individual profiles that you want to include until you get the right combo. If you'd like, however, you can go back and edit your sketch and trim it until it matches what you want. So I'm going to go and hit T for trim, and I have a choice here. I can hover over geometry until it shows red and select it until I get rid of everything that I want to get rid of, just like that. Or, oh, and also this one as well. Or let's go and undo that just a little bit. There we go. I could hit T for trim, and I could simply drag my mouse through each of these geometries until it matches what I want, just like that. Now I have a single profile, and it makes extruding even easier because I only have one profile to select. Let's go and add a dimension to this, and we'll go with 5 millimeters. And this is looking much more realistic. And if you want to see this on the faceplate, here you can see the faceplate itself and then my extrusion. And this is looking pretty good, except if I put in my bolts, I don't think they're actually going to hold on to anything. I need to tweak this just a little bit. So let's go and add some draft. And there are a couple of ways you could do this, by the way. I could have intentionally not put holes here, and then I could use our create hole. Where is that? Right there, or hit H for a shortcut. And by the way, if you ever can't find anything, hit the letter S for search, and you can just start to type in hole and then go into the hole command. And here in the hole command, I could choose a variety of different types of holes, whether it's a simple hole or it's a counterbore or a countersink. And in this case, realistically, I do want a countersink, so I can go and choose a countersink. I could choose where I want it, and then all of my different dimensions. Another way you could do this, in this case, is I could go and add draft, and we're going to go and choose this surface, this face, as well as this one. And we're going to go and add 45 degrees, hit OK, and now you can see that I have that drafted surface, or like that recess, but I still need to cut a hole through this as well. So let's go and hide our faceplate, and we'll show our original sketch. And that original sketch of the faceplate, we actually had two holes. We had the bigger hole for the size of the head of our screw, and then we also had the smaller one, which is the size of the hole that I need to make for that screw, for the threaded area. So we can go and hover over the back side and select these two regions, hit extrude, and we can cut through our model. I could pick a distance, or to make sure that no matter what I do to change my model, it'll always work, I could say through all and make sure to cut my actual piece. And now this is looking fantastic. At this point, I think we're ready for fillets. So I'm going to go to Modify, Fillet. I could choose the top edge here, and I could drag my arrow until I'm happy with the size visually, or I could type in a value like 1 millimeter, and I'm good to go. I could do the same thing on this edge and this one. We're going to go and type in a value of 1. And then I'm going to go and do this one last time over on this edge, and this time we're going to go and use 0.5 millimeter. And now this is looking really, really good. If I'm interested in 3D printing this right away so that I could see if this is going to work, I could simply go under Tools, Make a 3D Print, select the object that I want to go and 3D print, and all you have to do is make sure that your slicer is set up over here. Once you have it set up, all you have to do is hit OK, and your slicer is going to open. In this case, I'm using FlashForge Creator Pro. I have a FlashForge Creator Pro, and so I'm using the Flash Print Slicer, but I could also be using other software like NetFab or anything else you want, Cura or whatever it is. And then here is where I'm going to go and choose the different settings I want. I don't have any overhangs on this particular design, so I don't have to worry about any kind of support material. All I'd have to do is go and choose the different options I want, whether I'm going to choose the temperature, the material, and just a little tip for you. I talked earlier about how there are different things in this design that will each affect the overall flexibility of your part. 2 of those things are found right here in your slicer, whichever slicer you happen to be using. That's going to include your infill, like how dense is your part, because most 3D printed parts are not 100% solid. They're printed hollow on purpose, and how hollow the part is going to determine part of how strong it is or how flexible it is as well. So please make sure to pay attention to the fill density. I would say start with 15%, maybe work up to 20 if you want stiffer. 25 is pretty much my maximum. I don't really go above that. And then also I would look at your perimeter. And what your perimeter is going to do is it's going to define how many times your 3D printer is going to go around the perimeter and build a solid wall. Because the outside is always going to be solid, it's the center that gets hollowed. And in this case, I have 4 shells. I think the default with this slicer is 3, but you can change this from 3 to 4 or 5, whatever you want. The higher the number, the stiffer your part is going to be. So just keep in mind that you can change the shell count and you can change your infill density, and that will very much have an effect on the flexibility of your part. Now let's go back into Fusion and let's talk about this part some more. The other different things you can do to change the flexibility of this part would be to change your width of this region right here, and we set that to 5 millimeters. You can make that thinner if you want it to be more flexible, and of course wider to be more stiff. You can also go and change the overall height of your part. That was defined here under this extrude, and we set that to also be 5 millimeters. You can change this taller to be stiffer and less tall to be, or thinner to be more flexible. You can also lastly go and change this pivot. And so if you look right over here, we define this at 60 degrees. Let's go and make this driven so I can go and modify this. Depending on where this particular flexing part ends, that will determine how much of this part is actually going to flex. So if you go and make this really small, all of the bending is happening in this region right here. And if you go and move this all the way over there, you're going to see more of the bending is happening here, but a lot of the bending is also going to be shared between all of the areas in between. So if you want your part to be stiffer, you can drag this over to the right, and if you want it to be more flexible, you can also drag this over to the left. But all of this at the end of the day is going to be up for you to play with and see what you like. In my opinion, the first thing you should do is design the part and 3D print it right away with whatever settings you'd like. Because no matter how much you want to nitpick your design in the computer, it's all about holding it in your hands. You can guess all you want about how stiff or not stiff this is going to be, but it's holding it in your hands that's going to tell you the answer. So my personal recommendation is to 3D print often, so that you get more feedback on your design. So you 3D print it, based on what you see, you make a change, you 3D print it again. And I went through several of these until I got one that worked well. The dimensions that you see on the screen and have been on the screen this whole time, those are dimensions that have worked really well for me. But of course, you can change this however you want until you find something that works well for you. But when you're done, you should end up with a piece that looks something like this. Feel free to change this however you'd like. And this is what it looks like on the faceplate. And feel free to change the design not only for aesthetics, but if you have another way to make this more functional, please do that. I have one example for you. This is actually a failed example, believe it or not, because as much as I like to win with Fusion 360, you have to fail in order to get to the point of winning. So after I made my first guard, my light switch guard, I decided, wouldn't it be nice if I could prevent my son from being able to not only turn on the fireplace, but also turn it off when I intentionally turned it on. So here you can see that I made a double guard. And this double guard is going to prevent the switch from turning on when you don't want it to, and off. Basically, whichever way it's already right now, it's going to stay that way unless you bend the arm out of position, right? A toddler couldn't do it, but an adult, of course, can. One thing to keep in mind with plastics is that plastics, when you put them under a load or a force for an extended period of time, they will end up doing something called creep or creeping. And what that means is that they become accustomed to being in that shape and they don't want to flex back to the original position. So what I found very quickly when I made this double guard is that if I had the light switch up on a regular basis, then the guard that would be bending out of the way, this top one in this case, would stay off all over to the side. And then when I moved that light switch down, it didn't actually work anymore. And conversely, when I had light switches that were down all the time, basically one of these two arms would always not work. So keep in mind, it's all about experimenting. Even someone like myself, I know Fusion 360 really well, and yet I'm learning something every time I design. So this was a complete failure. I do not recommend the double guard, but the single is absolutely perfect. Also keep in mind, if you would like to design using my files as a starting point, I've included a link to this particular design in the description of this particular video. Click on that link, download a Fusion 360 archive of the design, upload that Fusion 360 archive into your Fusion 360 account, and you can see step by step all of the different steps that I use to create this design. And that's going to include both the faceplate itself as well as the light switch guard. In conclusion, I hope you can see that Fusion 360 can be incredibly beginner friendly. We went ahead and we created two sketches, one for the faceplate and one for the actual light switch guard. We then extruded that light switch guard. We added a chamfer, a drafted surface, and then a hole to be able to make the position for the bolts or the screws, and then we added 3 fillets to smooth everything out. But today we really focused on sketching, right? It's all about sketching. To me, sketching is the fundamental skill that's going to translate into you being a good 3D modeler. Don't skip on it. Don't go straight into the 3D stuff. Start with sketching, get good at sketching, because if you are good at sketching, the rest will follow very easily. And if you're struggling on the 3D side, you might find that it's because you're struggling in sketches. It was my pleasure to host today's Fusion 360 Live webinar. I hope you enjoyed designing something easy and practical. Please tune in to Fusion 360, our YouTube channel, for more videos, and don't forget to subscribe. I hope you go out there and you make anything. Thank you.